from the equations of these lines, we can get really the most important, well, one of the two important pieces of information. From this equation, we can read off the vector that's parallel to the line, a vector that's parallel to the vector, and we'll call that vector v, and we see that that's 4i plus 7j minus 5k. And this line is parallel to vector that we can just see right here. Now we're going to call that vector w equals negative 2i plus 4j minus k. So that we have two vectors, one parallel to this line, one parallel to this line. PQ is a vector that's perpendicular to both lines, makes right angle with both lines. How do we get a vector perpendicular to two lines if we have vectors parallel to the lines? Well, the cross product of two vectors is perpendicular to both vectors, so v cross w is going to be perpendicular to both lines. So v cross w is perpendicular to both lines. Now we can calculate v cross w. That's a straightforward calculation. And we can do the determinant I, j, k multiplied by the vector, well, with the components of the vector v, the components of the vector w, and I'm going to do this rather quickly and probably make a mistake, but let's see if we can do this right. So that's I times the vector, I times the determinant, 7, negative 5, 4, negative 1, minus j times the determinant of 4, negative 5, negative 2, negative 1, plus k times the determinant of 4, 7, negative 2, 4. And if I do my arithmetic correctly, that's going to be negative 7 plus 20, which is 13i, minus, okay, negative 4 plus 10, so that's minus 6j, and then 16 plus 14 plus 30k. So this vector is perpendicular to the vectors that are parallel to these lines, so that we know that our vector PQ is parallel to this vector. If then we can find points, a point on each line, we can form the vector between those points and project it onto PQ and obtain the distance between the two lines.